Hi everyone and welcome back. If you have been following along with this series, you will remember that in our last videos we have covered functions and object-oriented programming, two essential building blocks in Python. If you have missed those, don't you worry, I have linked them in the description below so you can check them out. Today we are taking the next step and diving into Python modules. So I want you to think of modules as a way to organize and reuse your code, especially as your projects start to grow. So instead of putting everything into one big script, modules will help you and will let you break things down into smaller as well as more manageable pieces that you can import whenever you need them. So in this video, we'll go over what modules are in Python and why they are so useful. We will then cover the benefits of using modules such as reusability and readability and maintainability. We will also look at how to load a module into your Python code and the idea of Python packages, which let us organize multiple modules together. And to bring it all together, we will finish with a hands-on demo where we will reuse the classes from our previous video and modularize the code to make it more efficient and manageable. And of course, run it end to end. So by the end of this video, you will have a clear mental model of modules and the confidence to use them into your own automation work. Alright, so before we dive into the details, let's answer the big question. What exactly is a module in Python? So when we talk about modules in Python, we're really just talking about Python files. A module is any file with a .py extension that contains Python code. So inside that file, you might have functions or classes or variables that you have written. And the beauty of modules is that once you have written that file, you can bring it into other Python programs with a simple import statement. For example, if you create a file called networkutils.py with a function to ping a device, you can use that function in any other script just by importing the module. It's like building your own custom toolbox that you can carry into different projects. Now, Python itself ships with a huge number of built-in modules. So think of the math module, for example, which gives you access to mathematical functions like square roots, for example, or the datetime module, which handles dates and times without you needing to reinvent the wheel. So when you write import datetime, as you see on the screen, what are you doing is telling Python, hey, grab that file full of code that already knows how to deal with dates and times and let me use it here. So in a sense, modules are just pre-written code that is organized into files that we can pull into our scripts whenever we need them. But here is why modules really matter so much. They give your code structure and reusability. So without modules, all your code would live in one massive script. So I want you to imagine if you have a 600 lines Python file where you have got SSH functions and parsing functions, reporting functions, and error handling all jumbled together. It's a nightmare to read or update or even fix. So by moving code into modules, you separate the different responsibilities into neat, manageable files. That means you can go straight to the file that handles, let's say, for example, device connections without having to sift through the whole project. So another big advantage of modules is reusability. So let's say you wrote a handy function called ping host in your networkutils.py module. If you didn't use modules, you would have to copy and paste that function into every script where you need it. Now, imagine later on you find a bug in that function. You would have to go and fix it in every single script. And that's just asking for mistakes. So with a module, you only maintain one copy of the function and every script that imports it gets the updated version automatically. Modules also help with avoiding conflicts. So in your project, you might have two functions called connect, for example, one that connects to a network device and another that connects to a database. So without modules, that can be confusing and a little bit dangerous. So with modules, you can keep them separated and clear. For instance, you've got SSH connector.connect versus DB connector.connect, as you see on the screen. The module name acts like a label, making it obvious which piece of code you are calling. And finally, modules open the door to the entire Python ecosystem. Beyond the built-in ones, you can install third-party modules like Netmiko or Paramiko or requests. These are professionally built and tested tools you can just plug into your project. Instead of spending weeks writing your own SSH library, you just import Netmiko and get going. So to sum it up, modules in Python are just files contains code, but their impact is huge. They help keep your work organized as well as reusable and easy to maintain. They prevent naming conflicts and make your scripts cleaner and give you access to a vast library of built-in and third-party tools as well. Once you get comfortable with modules, you will find that they are not just convenient, they are essential for writing Python code that scales beyond tiny scripts. So now that we know what modules are and why they are so valuable, the next step is to figuring out how to actually use them in our code. And the good news is Python makes this really straightforward. So when you start working with Python modules, the first and most straightforward to bring them into your project is by using the basic import statement. This means you are pulling in the entire module so you can access all of its functions, classes, and variables. So for example, if you import the math module, you can then use it by calling things like math.sqrt to get the square root of 16, as you see on the screen. It's simple and clear, but the trade-off is that you always need to type the module name as a prefix, which can sometimes feel a bit long if you are using it repeatedly. Now, that's where the alias import comes into play, using the keyword PD, for example, as you see on the screen. So with this approach, you can give a module a shorter name, making your code cleaner and quicker to write as well. So for instance, instead of always typing pandas.dataframe, you can import pandas as PD and just write pd.dataframe, as you see on the screen. This is especially helpful for modules with long names or ones that you will use often throughout your script. It's really about readability and convenience, nothing more. So sometimes though, you don't need the entire module, you just want a specific piece of it, which is fine. And that's when you use the from import statement. So let's say you only need the square root function from the math module. Instead of importing everything, you can write from math import sqrt or the square root function. This way, you can call the square root 25 directly without having to prefix it with math every time. And of course, it makes your code feel lighter and more focused since you are only pulling in what you need. So taking it one step further, you can also apply an alias to these individual import using the from import as style. Maybe you are using a function like factorial often, but typing it out in full feels tedious. You can import it as fact by writing from math import factorial as fact. Now you have got a shorter and more convenient name for the same functionality. This keeps your code concise while still being clear about what's going on. Finally, there is the from import star option, and often referred to as the import all approach. This brings in everything from a module directly into your current script. So you don't need any prefixes at all. So for example, from the math import star lets you call sen or use the constant pi immediately. While this can be handy in quick experiments or small scripts, it's generally not recommended for larger projects. And the reason being is that it can clutter your namespace and even cause conflicts if different modules have functions or variables with the same name. So it's like dumping all your tools into the table at once. It is convenient, but a little bit messy. Okay, so we have seen how modules help us organize and reuse code, but what happens when your project starts growing even bigger? That's where Python packages come in. So, at the core, a package in Python is simply a way of organizing multiple modules together into a single directory. If you think of a module as a single toolbox, then a package is like a large tool chest filled with multiple toolboxes. So each toolbox or module has its own set of specialized tools, but the package keeps everything neat and structured. So technically speaking, a package is just a directory that contains an init.py file along with one or more module files. So that init.py file signals to Python that this directory should be treated as a package, not just a regular folder. So imagine you are building a package called network tools. Inside this package, you could have different sub-packages and modules that reflect different aspects of your project. So for instance, you might create a protocols sub-package that contains files like ospf.py and pgp.py and eigr.py, each file handling a specific routing protocol. And of course, this keeps all protocol related logic in one place, making it easy to expand or maintain later. But protocols are only one part of a bigger project. So next to it, you might have a services subpackage, and this is where you would place modules that actually do things with devices, such as device backup.py to pull configurations from routers or end devices. You also can put compliance checker.py to verify configs against policies, or report generator.py to create output reports. So these services typically rely on protocols or connectors, but focus on delivering high-level outcomes. So alongside services, you might also have a config subpackage. This folder could contain files like templates.py for storing Jinja 2 configuration templates. So, in other words, this is where you define what gets pushed to the network, while services handle how it gets done. Finally, you would almost certainly have a test subpackage, and this is the part of the project that ensures everything works as intended. So inside, you might place test connectors.py for verifying SSH connections. So by separating tests into their own package, you keep development and validation tightly integrated but still neatly organized. And of course, just as Python comes with built-in modules, it also comes with built-in packages. So for instance, XML is a package that contains multiple modules for parsing and handling XML data. But what really powers modern Python development is the massive ecosystem of external packages you can install using the pip tool. So packages like requests, Flask, and Netmiko are not just modules, but structured packages containing multiple modules that work together to provide powerful functionality. So working with packages feels very similar to working with single modules. You use the import statement, but specify the path through the hierarchy. So for example, you could write from network tools.services import device backup, as you see on the screen. And of course, this gives you direct access to those modules within your project. So in short, while a module is a single Python file, a package is a collection of modules and sometimes subpackages bundled together. So by creating subpackages like protocols, services, config, and tests, you can structure your project into logical parts. And this organization makes it easier to grow from small scripts into large, maintainable, professional-grade applications. Now that we have covered the theory behind Python modules and packages, it's time to bring it all together with a practical demo. We will take the concept we just talked about, like splitting our code into separate modules, also importing them into a main script, and reusing our classes and actually see them in action. This way you will not only understand the what and the why, but also get a clear picture of the how. So let's jump into the demo and see how everything works end to end. When we run the tree command on the folder we used in our last lesson, it will show that you have the layout of that folder. So let's go ahead and execute that command. So I'm going to say tree dot dot forward slash 014, and then I'm going to hit the tab to auto-complete it, and then I'm going to hit enter. And as you can see, the output reveals that inside this directory, there is only a single file called python_classes.py. No additional files or subfolders exist there. It's very straightforward structure with just one Python script sitting inside that folder. Also, you can see at the bottom of the output, you will notice the line 0 directories and one file. This is a quick summary that tells you the folder doesn't contain any other directories and has only one file in total. It confirms the simplicity of this particular setup. Now I'm going to execute the tree command without specifying the directory, so we can look at the current directory where we at the moment. So I'm going to say tree and I'm going to hit enter. Now you can see that at the very top you will find the project folder, and inside it there are two main things. Main.py, this is your main script, the file you actually run to kick things off. It's where we import the classes or functions from other modules and tie everything together. This is the file that uses the classes we built, like Cisco Switch and Cisco Router, and actually connects to devices. It also sends commands and applies configurations. The network automation is a directory that acts like a Python package, and inside it you have network device class.py, which contains the reusable classes we created earlier. And those classes that we created in our last video, network device class, we also created the Cisco switch and the Cisco routers, which inherit functions and variables from the network device class. So by keeping them in their own module, your code stays cleaner and more organized. And of course, you can reuse those classes in different scripts without having to rewrite them every time. There is also a PyCache folder inside network automation folder. That happens because Python automatically generates this when you import a module. So it stores the compiled byte code or .pyc files, which helps Python loads modules faster the next time round. You don't need to touch or edit those files. They are just created and managed by Python behind the scenes. Now, let's take a quick look at the code. And by the way, I have already explained how this code works in the previous video. So if you missed that, or if you would like to understand it in more details, you can check out the links below in the video description. So in this project, we have got a couple of import files. The first one is main.py, which is our main program. And the second one is network device class.py, where we have defined the class for our network devices. Okay, so let's start by walking through the network device class.py first together. And then we're going to shift our focus to the main.py file. So the first line, we are importing the connect handler class from the Netmiko library. And the second one, we are importing two specific exceptions from Netmiko. These are basically error types that we might run into when something goes wrong. So we have created a class called network device, and that class has an init function or constructor. And also there is the connect method where we initiate a connection to the end device using the connect handler. Then the disconnect method, where we disconnect from the end device gracefully. And finally, the send command method that sends commands to the end device. There is also a Cisco switch class that inherits from the network device class all its methods and variables. It has a unique method to it, which is the send config command that pushes configuration changes to the end devices and related to switches or switch devices. Finally, we also see the Cisco router class that is similar to the Cisco switch class in that it inherits all methods and variables from network device. Again, it has a unique method that sends configuration changes to the end device. Okay, so with that being said, let's shift our focus into main.py. So the first line where the magic really happens. This line is simply telling Python to bring in two specific classes. These are Cisco Switch and Cisco Router from our custom module called Network Device class, which lives inside the network automation package. So by doing this, we can use those classes directly in our program without having to rewrite all the code that defines how a switch or a router should behave. It keeps our project clean and organized because the device logic is stored in its own file, and our main program can just import and use it when needed. This is one of the big advantages of using modules and packages, as it helps us separate responsibilities and makes the code much easier to manage and reuse. So this block of code is basically the entry point of our program, and inside this section we are testing how our Cisco switch and Cisco router classes work in practice by connecting to a switch and a router, running some show commands and pushing configurations and then disconnecting. So the switch example comes first. We create a Cisco switch object with login details, try to connect to it, and if successful, we run a command show VLAN brief to check the VLANs. Then we push new configuration commands to create VLAN 10 and give it a name. So after that, we run the same show command again to confirm that our changes took effect. And finally, we disconnect from the switch. The router example works in a similar way. We connect, we run a show command, in this case is show IP interface brief. We configure a loopback interface and verify the configuration and then disconnect. If either device can't be reached, the script prints a simple error message. Okay, so with that being said, we can go ahead and execute the script and check or observe the output. But before we go ahead and do that, let me go quickly to my secure CRT application and let's check the current configurations on each device. So we have router 1 on the left hand side and switch 1 on the right hand side. So on the router, I'm going to say show IP interface brief. And as you can see on the screen, there is no loopback has been configured yet. And if I go to switch 1 and issue show VLAN brief, I can see that VLAN 10 has been created already. So I'm going to go ahead and remove that VLAN from the switch, and then we're going to verify that. So at the moment, you can see that we have removed VLAN 10. We have deleted it from the database or VLAN database. And we also reissued the show VLAN brief. And you can see that VLAN 10 is no longer exist. So now I'm going to go back to my script and I'm going to execute it and examine the output. So as you can see on the screen, we have successfully connected to switch 1, which has an IP address of 192.168.1.2. We also revealed the current VLAN assignments. We have then applied the configuration successfully since we've received that message, as you can see on the screen. And then we revealed the same command, which is show VLAN brief. And now you can see that VLAN 10 for the account department has been created successfully. We then disconnected from the switch. We have then connected successfully to router 1 that has an IP address of 192.168.1.1. We issued the show IP brief command, and you can see that there were no loopback interface being configured. We applied the configurations and that was successful, and then we reissued the same command, which is show IP interface brief, and you can see that loopback 0 is configured with an IP address of 10.10.10.10, and this configuration was pushed successfully. We then disconnected from router 1 and the script ended then. So this structure gives us a practical end-to-end demo of how to use the classes we wrote to automate real device operations. So that's it for this video. I hope it was informative for you, and if you found it helpful, please don't forget to give it a thumbs up, and if you haven't already, please hit that subscribe button and turn notifications so you never miss our future tutorials and tech insights. If you have any questions or thoughts, feel free to drop a comment below, and to read more about this topic, be sure to check out my blog. You will find the link in the description below. And remember, consistency and hands-on practice are key to success, so stay curious, stay inspired, and until next time, peace.